All right, hello again. So this time we're going to go over groups, and in particular we're going to look at definitions and examples. And this goes with the groups, definitions, and examples section of the notes. So first of all, what is a group? A group is a set. So a group is a set G with a binary operation and that operation, we're usually going to write it as either multiplication or addition, and it's going to be a map from G cross G to G, which means that it takes two elements of G and spits out another element of G, satisfying some extra conditions. So first of all, our operation, I think for my definition I'm going to use the multiplication sign. So we'll write this as multiplication. So there has to be an identity element. And that means that there exists some number which we'll call, or some element of G, which we'll write as 1, or if we really want to keep track, we can call it 1 sub G, such that 1G times X is equal to X times 1G is equal to X. Now, before we move on from this one, I just want to note that when we're working with an additive group, so one where we're writing a plus sign, we often write the identity as 0, because the identity when you add is usually called 0. So we're also going to require that the product is associative. So that says that for all A, B, actually let's keep our variables consistent, huh? So how about X, Y, Z, and G, X times Y times Z is equal to X times Y times Z. Simple enough. And then third, we're going to require that inverses exist. And how I usually think of this is if I can get somewhere, then I should be able to get back if I'm in a group. So for all X in G, there exists something that we'll call X inverse, such that X times X inverse is equal to X inverse times X is equal to the identity. So you can always get back to the identity. And that's it for our definition. So in particular, that last thing I said, that you can always get back once you've gone somewhere. Now that we have inverses, we have a notion of equations, right? So if we have H and I go somewhere by multiplying by G, I can get back to H by multiplying by G inverse. Now associativity says that this is G inverse times G times H equals H. Okay, yeah, so starting from H, if we go by G, then we can use the inverse to get back to H. Simple enough. Now, there's one more piece that we often have. So if you think of addition or multiplication of integers, or rational numbers for that matter, there's another one which we'll call for star, which is commutivity. Which says that for all x, y, and g, x, y is equal to y, x. Now, I want to be really careful here and draw a second line here, because if our group satisfies 4, then we call it a commutative group. So group satisfying 4. Fix that up. This is called a commutative group. And sometimes it's called an abelian group, after this guy Abel, who apparently studied them a bunch. Those are the same thing. Usually, when we're talking about additive groups, they'll be commutative. Multiplicative groups, there's no guarantee. Some multiplicative groups are commutative, some are not.